Hello and welcome to lesson 3.6. My threes are horrible. Sorry, we're closed. Okay. Um, let's kind of graph. Let's get ready to go, right? And let's graph. Number one, letter A, graph f of x equals to 2/3 x plus 4. So for this, I want to make a note that I want to find my y-intercept. My y-intercept is equal to what? 0, comma 4. Okay. How do I know that? That's when x equals 0. And as well, this is written in slope-intercept form. So my slope here is 4. So 4. And now, let's think about 2/3. So my slope is equal to 2/3, positive, right? That means that it's a change in y over the change in x is equal to 2 over 3. So I have to go up how many? 2. So 1, 2. And to the right, how many? 3. So 1, 2. Let's do it. So 1, 2, and then 1, 2, 3. That's my other point. Okay. Now, what do I do next? How do I find the points over here, right? So for that, you work backwards. So you have to go down 2. So 1, 2, and then 3 to the left. So 1, 2, 3. So 1 right here. Okay. Why is that? Okay, because if I'm here, to get to this point, I go up 2 and to the right 3. So if I work backwards, you have to do the opposite, right? So going down 2, 1, 2, 1, 2, 3. It's right here. So now I can combine all these points and then connect the dots. Put little flechitas. Flechitas means little arrows. And let's kind of go to the next question. Use the graph to find when f of x equals 0. Okay, so when does f of x equal 0? This is when y is equal to 0. So when is y equal to 0? Right here, right? At what value is that? -6. So x is -6. Okay, that's how you would do it algebraic, graphically. Now, algebraically, you set that 0 is equal to 2/3 x plus 4. So you subtract 4 now, so you get -4 is equal to 2/3 x. And then to solve for x, you multiply by 3/2 on both sides. Okay? So you get that x is equal to -12 over 2. You get that -6 is equal to x, right? So we get the exact same answer. Now it says use the graph to find the value of f of 0. So you use this graph. So f of 0 is when x is equal to 0, y is equal to 4. Okay? Again, we found that earlier on as well. Okay, very good. Let's go to number 2. So now they want us to graph g of x equals to -1/2 x plus 3. Okay, so then you start at +3. That's your y-intercept. So my y-intercept is 0, comma 3. So we start at 3 right there. Okay, and I'm going to go change in y over the change in x is equal to -1/2. So again, I'm going to go down how many? Going down 1, and to the right, how many? 2. This is your other point right there, right? Going down 1, and then 2. So right there. Going down 1, and then 2. Going down 1, and then 2. Okay? Now I'm up here. How do I find the points over here? So I'm going to go up. So 1, left 2. 1, 2. 1, and then 2. 1, and then 2, right? Okay. And now we can connect all these little points. Here, 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 here. Something like that. Okay, cool. Now, when is g of x equals to 0? That means when y is equal to 0. So then let's kind of y equals 0, this is right here. So what x value is that? When x is equal to 6. Very nice. So here, g of x equals 0 when x equals 6. Okay, that's graphically. Algebraically, you can set negative 1 half x plus 3 equal to 0, and you solve, right? So you get negative 1 half x is equal to negative 3, and then you multiply this both sides by negative 2, negative 2. X is equal to positive 6. Okay? Use the graph to find the value of g of 0. So again, this is when x is equal to 0. So on our graph, x is equal to 0 right there. The point that it intersects is at 3. So g of 0 is equal to 3. Okay? So here, let's make it more clear. F of 0 is equal to 4. Okay? Good. Let's talk about 3. Okay. So graphing a quadratic. This is a quadratic. So quadratic. So it's a parabola. Parabola, right? Okay. So there's different ways to graph a parabola. And I'm going to kind of take you through what I think is the best approach to kind of graph a parabola. So let's talk about our vertex. So my vertex, my x coordinate, vertex, my x coordinate is equal to negative b over 2a. Okay, so again, this is in standard form. So let's kind of figure out, this is a, this is b, this is c. So what is a? A is equal to 1. B is equal to negative 2. And then c is equal to negative 15. Okay, so my vertex is going to be x is equal to negative b. So it's negative 2 all over 2 times 1. This is 2 over 2 equals to 1. So my vertex is at 1 comma something. How do I find what my y coordinate is? You have to plug it back in. So then I have to get h of 1 is equal to 1 squared minus 2 times 1 minus 15. 1 minus 2 minus 15 is equal to 1 minus 2 is negative 1. Negative 1 minus 15 is negative 16. Okay? So then my vertex is 1 comma negative 16. So then I have 1 point there. So at 1, where's 0? 0 is here. This is 1. So at 1, I'm down where? Negative 16. So right here's my vertex. What does that mean? That no point goes below that, right? All my points will be above. This is the point. This is the minimum point. The minimum point, okay? Think about that. That's your minimum. Now, let's kind of talk about this right here. This axis of symmetry, that vertex is also your axis of symmetry, okay? And now let's kind of find the roots. So we need to find the roots. So essentially we're solving part B before we can graph this, to me at least. So h of x equals to 0. This means that it's going to be x squared minus 2x minus 15 is equal to 0. This is to find the roots, okay? So then you can do quadratic formula. I'm not going to do quadratic formula here. I'm going to factor this out. This is going to become x. How do I factor this minus 15? I need numbers that multiply to 15, negative 15, but add up to negative 2. Okay? So think about 1 and 15, 3 and 5. So 3 and 5 to me sound like a really big one, right? So then this is going to be a plus and a minus, right? And then I need to have a minus 5 plus 3 equals to 0. So then I get that x is equal to negative 3. Well, let's set them equal to each other. X plus 3 equals to 0. So then x is equal to -3, x minus 5 equals to 0, x equals 5. So those are the roots. So this also helps us find part B. So those are my roots. So let's kind of go over here. So at -3, 0, 1, 2, 3, right here is one of them. And at 5, we have another one there. Okay? So we are pretty much very, very close to finding this. Let's use C. Use the graph to find the value of h of 0. Why is that going to be important? Because h of 0 is the what? The y-intercept, right? Okay. So then h of 0 is equal to 0 squared minus 2 times 0 minus 15. So then h of 0 is just equal to -15. So then add 0, we are at -15 right there. Okay? So how does that help us? So it helps us to note that now we can connect these points. But do we need other points here? How can we be sure that those are going to be the best points? Okay? So I would suggest that we do plug in more values in. Okay? So I'm going to make a table here because it seems impossible to do this without having more points. So we know that this is there. We know that's 5. We know 0. And we know one of them. So let's kind of go to -1. So, oops. So this is x. This is h of x. So at -1, we can plug it into this, right? So we can get, or we can plug it into this one, whichever one you feel more comfortable with. So at -1, I'm going to plug it into this. So -1 plus 3, -1 minus 5 is equal to 2 times -6, which is equal to -12. So at -1, I'm at -12 right there. Okay. So what should I also know? That this is my axis of symmetry, right? Think about that. This is symmetrical. So if I have, from this axis, there's 2 there. So then right here, I should be there. And then right here, this is 1 symmetry. So I should have another point right there. Okay? So that's kind of our kind of thought process to some extent that we should be thinking about, and the properties of symmetrical, like a symmetry, right? Okay. And then let's try -1. We try -1. Let's try -2. So then -2 would be -2 plus 3 times -2 minus 5 is equal to 1 times -7, which is equal to -7. So at -2, 1, 2, we are at -7 right there. So from the axis of symmetry, I keep talking about the axis of symmetry. The axis of symmetry is right here. And it's at the x equals your vertex, right? So my axis of symmetry here at -2 means that I am 1, 2, 3 units away from it. So then here, I should also be 3 units away from it. So 1, 2, 3. So right here is my other point. Okay? And I think now, let's pick some of these top points over here. So let's use -5. Okay? So then let's do -5 plus 3, -5 minus 5 is equal to, this becomes -2 times -10, which is equal to 20. So that's way out there, up in the sky. So -5, 20, somewhere, no, I'm not even gonna graph that, right? So I think for today's video, I think it's purposeful if we choose maybe like -4. Let's try -4. So -4 plus 3, -4 minus 5 is equal to -1 times -9. That's equal to 9. So at -4, we are over here at 9. And then Again, symmetry. So 1, 2, 3, 4, 5. We're 5 units away here, so over here we should be 5 units to the right. 1, 2, 3, 4, 5. So right here. Okay. So then we now have those points, and I think this is going to be our best bet at drawing these. Well, I messed that up completely, right? It doesn't have to be perfect. That's what I'm going to tell my students. Something like that. So that was a lot of work, I would say. And I think it's important to note that I found my vertex was like step 1, vertex, right? Step 2 was find my solutions, my roots, because that's where it crosses it there. 3 was find my y-intercept. Okay? And then I used step 4. I used more points. Okay? And then for D, find the minimum value of h of x. So for h of x, we know that. So the minimum value for h of x is what? Negative 16. This is right here. This is the minimum. So it's when h of 1 is equal to negative 16. Okay? Now let's kind of graph this just because I feel like we need to, right? Y is equal to x squared minus 2x minus 15, right? So this is this graph here. Okay, cute. Let's graph our other equation to see we're right. So x plus 3 times x minus 5. It should be the exact same what? The exact same one, right? So here we see that they're overlapping, so that's perfect. Good. Let's change our window a little bit. So my x minimum, let's make that negative 10 to positive 10. And my y minimum, let's go negative 20 to positive 20. And let's see how that looks. Okay. So again, this is your parabola. You can go to the table, second graph, and it gives you all these values, right? So at negative 4, we were at 9, so that's good. Negative 3, we were at 0, good. Negative 2, we were at negative 7. So you can use these points as well to kind of graph this. It all just does depend if we are using calculator or no calculator, okay? But yeah, so let's kind of talk about number 4 now. So number 4 is a little bit different, but a little bit of the same concept, right? So let's kind of talk about this in standard form, just because that's what I talked about earlier. So then k of x is equal to negative x squared plus 9. Okay? So very, very similar concept. Again, let's kind of talk about step 1. So step 1 was finding your vertex, your x coordinate. So that's equal to x is equal to negative b over 2a. So let's talk about a here is negative 1. B is equal to what? 0. And then C is equal to 9. So my x here is equal to negative 0 over 2 times negative 1, which is just going to be equal to 0. Good. That's kind of helpful for us in a way because we don't have to do a lot of work. Now we find k of 0 is equal to 9 minus 0 squared, so it's equal to 9. So my vertex is going to be where? 0, comma 9. Okay? So then 0, comma 9, let's grab that point right here. That's my first point. Okay? Now, step 2. What did I say earlier? Is that we have to find the roots. Okay? So that's literally question B. So 9 minus, so k of x equals to 0. That is 9 minus x squared equals to 0. And then we kind of solve for this, right? So then we know that 9 is equal to x squared, right? And now what can I do to get rid of this? I take the square root. So square root. What comes along with the square root? A plus and minus. So plus and minus 3 is equal to x. Okay, those are your two solutions. I could have done this a little bit differently too. So if I have 9 minus x squared equals to 0. Can I factor this out into a product of two things to factor it out? So this becomes 3 minus x, 3 plus x equals 0. And this is what I like to call a difference of squares. So a difference of squares can be thought about as a squared minus b squared equals a plus b, a minus b. So in this case, 9 and x squared are technically perfect squares, right? So I split this up into a product of two binomials, and I do get the same concept. 3 minus x equals to 0. I get that 3 is equal to x. Then 3 plus x equals to 0. I get that x is equal to negative 3. So those are perfectly valid ways to do this. I did it one way here and another way there, and they're the exact same. So that was my step 2, right? So I can graph these now. So at positive 3, I'm here. At negative 3, 1, 2, 3, I'm here. Okay? That was my step 2. Step 2, let's call that step 2. And step 3 was to find my intercept. So the value of k equals 0. This is my intercept. So then k of 0 is equal to 9 minus 0 squared. So that's also equal to what? 9. So then here, this is my vertex. That means this is the what? The highest it can ever go. And why is that? Because we figured it out. This was the vertex, right? If the vertex is the very top, how come I don't have points like that? Why not? Because where are the roots? The roots are over here, right? So this means that this has to be the what? Maximum, right? Or just the vertex has to be there, right? Okay. Now let's talk. I talked a lot about the axis of symmetry. So my axis of symmetry is where? At 0, right? This is the axis of symmetry, right there. Perfect. Now, let's find a table. I need to find more values, right? That's horrible. I need to find more values so I can plot this. So let's think about x, and this is k of x. So we found 0. Let's do 1. So then we get 9 minus 1 squared is equal to 8. So then at 1, I should be at 8 right here. And then because of symmetry, keep that in mind. This is 1 away. So then to the left, I need to be 1 away. So right there is my other point right there. Okay? Let's think about 2. I have 9 minus 2 squared is equal to 5. So then add 2, I am at 5. So then add negative 2, 1, 2, right here, I am also at 5. Okay? Let's try 3. 9 minus 3 squared is equal to 0, which we already found, right? Good. 3, 0 is there. So because of symmetry, there's another one right there. Okay? Let's do 4. So then we get 9 minus 4 squared is equal to 9 minus 16, which is equal to negative what? Negative 7. Okay? Negative 7. So then add 4, I'm down here at negative 7. 5, 6, 7. Okay? So then because of symmetry, this is 1, 2, 3, 4 units from the axis of symmetry. So then I need to go 4 left. 1, 2, 3, 4. So right here is my other point. Okay? So I think this is good for now. 5 won't really be on there. So we can now connect the dots and connect all these wonderful dots that we drew. Pretend this is perfect. Okay, cool. That is your parabola. Now, letter D. Find the minimum or maximum value of k of x. So what was the minimum or maximum? Do we have a minimum? So my minimum is going to be what? Negative infinity. Okay, don't really have to care about that. that one that much because we know that it's going to keep on going, oops, forever and ever and ever, right? So then k of x has a maximum at x is equal to what? At x equals to 0. The maximum of k of x is 9. Okay, perfect. Okay, now let's kind of jump into our set problems, okay? So it says to give an argument for the statement, the sum of the integers, of 521 and 1342 is always odd, okay? Consider the case where one of the given integers is negative, and write a statement about the sum of even and odd integers. Okay, so let's just think about what exactly is 521. So is 521 an odd number or is it a negative? So then let's think about this. So 521 is odd, and then 1342 is even. So let's actually find it. What exactly is the sum of them? So the sum here is 1 plus 2 is, well, let me do this a little better. So we have 1342 plus 521. This is 3, this is 6, this is 8, this is 1. So it ends up being what? It ends up being an odd number. Okay? So that's where we are, right? So we know it is odd. Okay? Um, but that's just for this is just for this particular numbers. So it starts to consider the case where one of the given integers is negative. So let's do this. Let's do 1342 plus negative 521. So what is that going to be equal to? That is equal to 821. How do we figure that out? We're subtracting, right? So 1342 minus 521. 2 minus 1 is 1. It's 2. And then here, 3 minus 5, we regroup, we borrow from our neighbor, a cup of sugar. So we're 821. This is also odd. This is odd. This is odd. Okay, now let's think about the other case where 1342 is negative. So we have negative 1342 plus 521 is equal to what? Think about that. It's going to be equal to negative 821. Okay, because it's the same concept. I'm going to be um, taking away from the negative. That's going to be a little bit more less negative, but it's still going to be the same concept as negative 821. Okay. This is odd. Okay, so they're both odd. Okay. So then what does that make you feel? What can you think about that? What numbers determine if this is odd? The 1 and the 2, right? So think about that. Um let's so adding, let's think about this on a lower scale, on a smaller scale, a small scale. If I have 2 plus 1, it's equal to what? 3. So this is an even, this is an odd, this is an odd. Okay? Now what if I have a 2 plus 2 equals 4? This is even, even, even. Okay? So what I'm trying to get at, oh, what am I missing? I'm missing an odd. So let's think about odd. So let's think about 3 plus 3 is odd. Odd odd equals to 6, which is an even. Okay, so we've done all the combinations that we could do. We did even odd or odd even, same concept, right? We did even even, and we did odd odd. So at the end of the day, the sum of even and odd integers. So the sum of two even integers, how do you spell integers? Integers. English is not my first language, okay? Is even. And then we get that the sum of two odd integers is always going to be what? Even, right? We did it in a smaller scale. And then we talked about the sum of an even and an odd is always what? Odd. Okay. So that's kind of where I think that that's a fair argument to talk about. Um, yeah, your answer might look different than mine, but as long as you make the connection that if I am summing these numbers up, if an even plus an odd give you an odd, okay? Even plus even would get you an even number, and an odd plus an odd gives you an even number as well, okay? Okay. For 6, write the polynomials that are analogous to the integers 521 and 1342. So that's just going to be 5x squared plus 2x plus 1 to the x to the 0 power. It's just equal to 5x squared plus 2x plus 1. Okay, let's kind of put those over here. Now this one, there's another one there, so that's going to be an x to the cubed plus 3x squared plus 4x plus 2, right? Well, x to the 0, which is just equal to x cubed plus 3x squared plus 4x plus 2, okay? Um, that's kind of how we should be thinking about those in terms of polynomials. Um, Now let's think about 7. Given two polynomials, p of x and q of x, the constant term in p of x is even, the constant term of q of x is odd. Would it be correct to assert that the constant term p of x plus q of x or minus q of x would be odd? Let's explain that. Okay. So what did I talk about earlier in question when we did it over here? What was it? They're telling us that it's even and odd. So even and odd was always going to be what? Odd. Okay. Um. So this is this adding polynomials is analogous. So to adding integers. Integers. How do you spell that? Yes. Okay. As stated in problem 5, um, adding an even and odd integer is always odd. So then here, p of x plus and minus q of x would be odd. Okay, so this is an interesting concept, right? I hope it makes some sense. But I think just realizing that from a small scale, right? Like I did here, when you're taking the sum of a even and odd, you get an odd, even and even, you get an even, and an odd and non odd, you get an even. Now, if you're thinking about what about subtraction? So subtraction, question mark. So when you think about subtraction, think about as adding the opposite. So for example, if I have like 7 minus 2, this is equivalent to saying 7 plus -2. The opposite of positive 2 is -2. So the same thing here. This is equal to 5, and this is also equal to 5. And here I have an odd, and I have an even. Um, wait, what? I have an odd number and I have an even number, which is this is an odd number. Yes, yes. Okay, sorry. I thought I was all wrong. But no. Okay, same concept. Okay, let's talk about the next part. So identify the following statements as sometimes true, always true, or never true. Okay, let's dive into it. Um, if your answer is sometimes true, give an example. Okay, important of when it is true, an example of when it is not true. If it is never true, give a counterexample. Okay, so the set of linear polynomials, linear, so that just means x, right? That's all it means. X plus 2, negative x plus 7 million, right? Okay, is closed under multiplication. So let's think about that. If I multiply, so let's think. If I multiply x plus 1 times x plus 2, is that going to be linear? No, this is never true. Never true. Because x plus, so let's think about it. So x plus 1 times x plus 2 is equal to x squared plus 3x plus 2, which is not in the linear. So this is in this is a set notation. So like this is not in the set of linear polynomials, right? Because that's quadratic. Okay. Okay. The set of all polynomials. So all polynomials, think about this as x squared plus 7 million. Polynomials, think about polynomials. What other polynomials do we know and love? Like x to the fourth plus 3x squared, right? Okay. They're all closed under multiplication. What is that going to be? This is always true, right? This is always true, right? Because I'm multiplying two polynomials. So if I multiply like x to the fourth plus 3x squared times x to the 27 plus, I don't know, 2x to the 600, right? It's always going to be a polynomial because we know that numbers are closed under multiplication, right? So the product of two polynomials will be a polynomial. Okay, think about that. Good. The set of cubic polynomials is closed under subtraction. So, okay, cubic polynomials is like x cubed, right? That's a cube. It's closed under subtraction. So that means that if I have a cubic polynomial minus another cubic polynomial, it's going to get me a cubic polynomial. So let's think about what I just said. Like x cubed minus 2x cubed is equal to negative x cubed, right? Okay. So which is indeed a cubic polynomial. But then let's think about if I had 2x cubed minus 2x cubed, that's equal to what? 0. So this example right here, number 10, is sometimes true. Sometimes true. Okay. Because for example, if I have like 9x cubed plus 7x squared, um, minus 5x cubed. It is equal to 4x cubed plus 7x squared. Good. But then, if, like I said over here, if I had 2x cubed plus x squared, and I had minus 2x cubed minus x, this is going to be equal to x squared plus x, which is a quadratic. So this is a quadratic. So it does not stay within cubic polynomials, right? So it's not close. It's sometimes true. Sometimes it works, sometimes it doesn't work, okay? Okay. The set of all polynomials, so all polynomials is closed under subtraction. So that's true, right? If you subtract a polynomial minus another polynomial, that essentially is true, right? This is always true. Okay. Good. Okay. The set of all polynomials is closed under division. So that's a big no-no, right? We know that this is never true. Never true. Why is that? Because division is not closed, right? Division is not closed. So what I mean by that is that if I divide, like let's say if I divide x squared plus 2x plus 1 all over x plus, I don't know, 1, right? This is not a polynomial. This is a what? It's a rational, right? So it's a rational function. So it just, we cannot, we just don't have that, right? This is not a polynomial. Okay, so this is never true. Okay. Solve each quadratic equation. Holy moly. Let's do some of these in a different piece of paper because I feel like this is going to get messy. Let's get messy with math, right? Okay. No, JK. Actually, never get messy with math. Be organized. With math, okay? So let's jump into it. So again, I'm gonna try my best to avoid. I will try my best to avoid a quadratic. My best to avoid the quadratic formula. The quadratic, right? I'm gonna try every other way that I possibly can to not do the quadratic formula because the quadratic formula is a monster, right? We do not like monsters in this class. So again, if I can do stuff differently by factoring and just simply solving, that would be best, okay? So let's kind of think about this as x squared minus 8x minus 33 is equal to 0, okay? So let's think about how can I factor this? So I want numbers that multiply to 33. So 1, 33, 3, and 11. 4 doesn't work, 5 doesn't work, 6 doesn't work, 7, 8, 9, 10, and 11. So that's where I'm back at it, right? So then I know that these have to work. So I have an x here, I have an x here, and now think about this is a minus 33, so there has to be a minus and there has to be a plus. There just has to be that. And then they have to add up to negative 8. So I'm thinking about 3 and 11. So 3 plus 11 is 14. 3 plus negative 11 is negative 8. Negative 3 plus 11 is equal to positive 8. So I want this one. This is the one that I'm going to go with. So it has to be x minus 11, x plus 3 equals to 0. Okay? You can double check your work by foiling this out, right? Okay. Now I'm left here. How do I do this now? So you set each of them equal to 0, and then solve. Okay, so x here is equal to 11, and x is equal to negative 3. So then those are my solutions, right? X is equal to -3, comma 11. Good. Let's talk about 14. 14. Okay. So same concept here. I'm gonna have x squared plus 4x plus 21 is equal to 0. Okay. Sorry, why did I do that? This is minus 21. Who do I think I am? Equals to 0. Okay. So again, I want numbers that multiply to 21. In particular, -21. So 1, 21, 3, and 7. 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 works, and I'm back at it, right? And so I know that they have to add up to 4. So here I'm going to have x, this is way too large, x here. And I want to have a plus and a minus, right? So there has to be a plus and a minus, and they have to add up to 4. So then 3 plus 7 is equal to 10. 3 plus -7 is -4. And -3 plus 7 is +4. So then it has to be a plus 7 minus 3 equals to 0. And then we just kind of solve everything. X plus 7 equals 0. X is -7. X minus 3 equals to 0. X is equal to 3. So then here, X is equal to -7, comma 3. Okay? Okay. It's like about 15. 15, 15. Okay. Let's see. Okay. So again, I don't like seeing it like this, right? I put it in standard form. X squared minus 2x minus 74 is equal to 0. Okay, this is kind of where I am with this. Think about what numbers multiply to 74. 1 and 74, 2 and 37, 3 doesn't work, 4, does 4 work? 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 doesn't really work, 11 doesn't work, 12 doesn't work, 13 doesn't work, 14 doesn't work, right? 14 doesn't work, 15 doesn't work, 16 doesn't work. And here I am thinking about numbers, multiples. 17 doesn't work. Nope, doesn't work. 18 doesn't work. 19 doesn't work. So what am I thinking about now, right? Like now I have very few numbers that actively multiply to 74. So none of these numbers actually add up to -2, right? So if I'm trying to do this by factoring, it has to be a minus and a plus, right? Now, these numbers just do not add up to -2 at all. Do you see that? Like, if I have 2 plus 37, that's 39. If I have -2 plus 37, this is 37. I have a 2 plus -37, this is -35. So they don't add up to that at all. So then my best bet now is to use the quadratic formula because I am not able to figure out any other numbers. So my quadratic formula, x is equal to -b plus and minus the square root of b squared minus 4ac all over 2a. Okay, and now I do have this in standard form, but let's label everything. So a is 1, b is equal to -2, and c is equal to -74, right? Okay, so then in my x world, in my quadratic formula, let's kind of plug in everything we know. So x is equal to -b, so my -b is -2. My b is -2, so times a negative, it'll be +2. So 2 plus and minus square root of b squared, negative 2 squared, minus 4 times a times c, holy moly here, all over 2 times a. So 2 times 1 is just 2, right? Okay. I'm going to wait a little bit to simplify the inside. So this inside becomes what? Negative 2 squared is 4. So it's 4 times 1 is 4 times negative 74. So I'm going to do this on the side. So 16, 7 times 4 is 28 plus 1, 29. So this is going to be equal to negative 296 all over 2. Okay? So x is equal to 2 plus and minus square root of what? Square root of 300 all over 2. Okay. Now, this is going to be a little interesting, right? So, in my eyes, I want to simplify this, right? So, I can simplify this, and this becomes x is equal to 1 plus and minus square root of 300 over 2. Okay? But now I need to simplify the square root. So square root of 300 can be thought about as 100 times 3. And this is a perfect square. So this is equal to 10 square root of 3. So x is equal to 1 plus and minus 10 square root 3 over 2. So this x is equal to 1 plus and minus 5 square root of 3. Okay. So there was a little bit of a jump here that I had to make. Where was that jump? The jump that I had to make was this part, right? You have to be able to simplify a square root. I figured out that 100 worked perfectly, right? 100 times 3 is a perfect square. Now, if you didn't think about it like that, totally fine. So think about small. So 2 times 150, okay? Now think about this as 2 times 75, right? And then think about this as 3 times 25. And then this is a perfect square, so hopefully you can recognize this one as 5 times 5. So then the way to simplify square roots is that you group together like terms in groups of 2. This is a 2, this is a 2. So what ends up being 5 times 2 is 10 square root of what was left, square root 3. This is the same thing we got. This and this were the same, okay? That's where I end up getting 1 plus and minus square root of times 5, 1 plus and minus 5 times square root of 3, okay? Let's do 16. 16. Copy. I think for the following, we're all gonna have to do quadratic formula for these. And the goal is for you to recognize when you can do that. That's kind of what I want you to learn from this, right? So think about this. Numbers that multiply to 2. So 1 and 2 are the only numbers that multiply to 2. But then they have to add up. So if I was doing this like this by factoring, this has to be a minus and a minus. So negative 1 plus negative 2 is negative 3, which is not equal negative 5. That means it's impossible, right? It's never going to be able to factor out perfectly. So that means we have to use our quadratic formula, right? So let me gonna go ahead and bring this down. Copy, paste this, perfect. And then let's kind of identify our variables. So what is A here? A here is just 1. B is what? Negative 5. This entire thing here is my B. And then C is just 2. Okay. Okay. So now let's kind of just, we're back to plugging in everything we know. So x is equal to negative b. So negative, my b is negative 5. Okay, I'm going to write it down so you can see it. And then we have negative 5 squared minus 4 times 1 times 2 all over 2. Okay, so then x here is equal to 5 plus and minus square root of negative 5 squared is 25 minus 4 times 1 is 4 times 2 is 8 all over 2. So I'm going to simplify this is equal to 5 plus and minus square root of 25 minus 8 is 17 all over 2. Okay, so then x is equal to 5 plus and minus square root of 17 over 2 is indeed your final answer. Okay, this is it. I can't simplify anything else. I can't divide this 5 over 2. That's how you should leave it. Square root of 17 is as simplified as possible. Simplified as possible. Or as it possibly can, however the English works out. Yes, right? Yes, that's kind of it. So this wasn't that terrible, okay? And let's talk about 17. Okay, now we have some bigger numbers going on here. And let's kind of just, I'm going to tell you how to do it 2 ways for the fun of it. Yes, math is fun, right? Yes, we love math. Copy. Let's go ahead and paste this here. Good. And again, how come I'm going straight into my quadratic formula? Why? Why am I doing that? Why am I even going there first? Why am I not even trying to factor out anything? Because factoring can be confusing, right? When we have this term here, right? I'm gonna tell you how to do it as well with the factoring. But I think quadratic formula can more than likely be our best friend when we have a leading coefficient that is not 1, right? Or negative 1 for that instance. So a here is equal to 2. B is equal to negative 7. I wish they had given us one that has a positive b so you can see the difference, but it's okay. And then c is equal to negative 4. Negative 4. Okay. So then again, we're back to plugging and chugging. So x is equal to negative b, that's just going to be 7 plus and minus square root of b squared. This is negative 7 squared minus 4 times a times c, negative 4, all over 2 times 2. Right? Now we have an a that is not 1, it's 2 now, so we have to make sure we multiply it. So if it wasn't clear enough, if I wasn't clear enough, I mean, this should be a 1, right? Because that's just kind of what it is, right? My a value is 1, but 2 times 1 is just 2, okay? So now here, let's kind of take it down, and we just say x is equal to 7 plus and minus square root of negative 7 squared is 49. So 49 minus 4 times 2 is 8. 8 times negative 4 is negative 32. Okay, all over 4. Let's take it a step further and let's simplify the square root. So here we have 49 minus negative, so this becomes a plus, right? You can think about it like that. That plus becomes 49, 59, 69, 79. 79 plus 2 is 81. Ooh, nice. All over 4. So then here, what do we know? We have x is equal to 7 plus and minus square root of 81 is 9 all over 4. Okay, so let's kind of actually do it now. So again, x is equal to 7 plus 9 over 4 and 7 minus 9 over 4. Okay, so then here x is equal to 16 plus 4 is 4. Okay, and x is equal to 7 minus 9 is negative 2 over 4, which is just negative 1/2. Negative 1/2. Okay. So these are my two solutions for this. And I used my quadratic formula. Okay. Now, I'm going to teach you or review a different way of doing this using the CAP method. So the CAP method is pretend you are picking up a taxi, right? That's what a cab is, for me at least. So CAB, okay? So I'm gonna kind of fly through this a little bit, but so this is number times a number, number times a number, number plus a number. Okay, so my C value here was -4, -4. Let me make this a different color. My C value was negative -4. My A was 2, and my B was -7. So I want numbers that multiply to -4 and to 2, but add up when I do them diagonally, they add up to -7. Okay? So this should be equal to -7, this should be equal to 2, this should be equal to -4. Okay, so let's think about some numbers. So the first one that comes to my mind is 2. So 2 has to be a 1 and a 2, right? That is kind of like standard. Now think about 4, -4 to be exact. So you can either have a 1 and a 4 or a 2 and a 2. Those are the only numbers that will work out. And one of them has to be negative. So let's think about this as let's think about if I put -2 and a 2, that's -4. And then let's think about this. They have to multiply down. So this becomes a 2, this becomes -4 to add up to -7. So this doesn't work. So you know that these do not work. They don't work. So what about 1 and 4? So let's think about this was a 4, this was a 1. Let's make this one a negative. So -1 times 1 is -1, plus 4 times 2 is 8. Does that add up to -7? No, but we're close though. We're really close. So what do you think we need to switch? This -1 becomes +1, and this becomes a -4. Now we got -8. And now we know that this is a true statement. Okay? And now these become our factors. So let's kind of highlight these here and these here. So this becomes 2x plus 1. This becomes x minus 4 equals to 0. So that is how you can factor this, right? Using the CAP method. Again, we set up our equations equal to 0. We get that 2x is equal to -1. X is equal to -1/2 is my first solution, which is what we found. X minus 4 equals to 0, and x is equal to 4. So both of these are solutions, which are the exact same ones we found over here. So again, this was done by factoring. Factoring. Okay? I used the quadratic formula. Quadratic. So again, two different ways of solving this. If you're able to factor it out, that might be easier. If you're able to do the quadratic formula, perfect, right? Same concept. I did rush a little bit on the factoring. If you know how to do it, perfect. If you want to learn how to do it slower, please come see me for office hours or review some videos. There's a lot of videos about factoring, either on Khan Academy. And this is frozen. What's happening? Okay, let's see. Good. Now the last one we're working on today is number 18. So again, I'm going to go straight into doing the quadratic. Okay, so let's identify our values. So A is equal to 3, B is -4, and C is equal to 2. Okay, let me copy and paste my quadratic because I don't want to rewrite it every single time, but you should. Good, cool. And now we're going back to the plug-in game, right? So x is equal to -b, 4, plus and minus square root of negative 4 squared minus 4 times a, 3 times c, 2, all over 2 times 3. Okay? X is equal to 4 plus and minus square root of 16 minus 4 times 3 is 12. 12 times 2 is 24. So we're going to run into something different. This is 24 all over 6. Let's kind of clean it up. X is equal to 4 plus and minus square root of 16 minus 24 becomes what? Negative 8. Oh my goodness, what is happening? We have a negative inside the square root. We've always talked about how we shouldn't have that, right? We can't have a negative of a square root because we're going to get a what? An imaginary number, right? So that's kind of the concept that we're talking about now. We are running into imaginary number world or territory, right? So let's kind of simplify this. This would become 2 plus and minus square root of negative 8 over 6. Okay, where did that come from? So I'm just dividing all this by 6, right? This can divide by 2, and this becomes 2 over 3, right? Now, let's talk about negative square root of 8, okay? So again, you want to treat this as just, think about this. So think about the square root of 8. So let's simplify the square root. So again, taking this small, 2 times 4, and then 2 times 2. So we know that these are pairing up together. So then we know that this is the odd one out. So the square root of 8 is equal to 2 square root of 2. So then as a result, square root of negative 8 is going to be equal to 2i square root of 2. Okay. So then here I'm left with x is equal to 2/3 plus and minus 2i square root of 2 all over 6. So x is equal to 2 over 3 plus and minus I square root of 2 all over 3. Right, so then you can essentially combine them up. You don't need to, but what I mean by that is that you can write them up as one single thing. 2 plus and minus I square root of 2 all over 3. Okay, these are your solutions. So I know this was a little bit rushed, I would say. Let me think about this. So where did this I come from? So we know that the square root of negative 1 is I. So you can think about, yes, that's where it comes from. So then you can think about as negative square root of 8, square root of negative 8 is equal to negative 1 times positive 8. So let me actually put this on the top. And let's kind of bring this over here. Okay, I think this is best. Yes, that's exactly why. Because you can think about this as a product of negative 1 times square root of 8, right? Because this is equal to negative square root of 8. And then think about this negative 1 as just I. So then times negative 1, so it's equal to I. Okay, so then that's where you get that it's a 2i square root of 2 comes from. Okay, yes, and then this is your solution. The CAP method here won't really be effective just because our solutions are not nice, right? Like over here, the solutions we got with the quadratic were nice, but in this case, they really weren't nice. So let me see how you would think about that with a calculator. So let's kind of just visualize this one, just because this one's a really special one, I would say. So let's go ahead and clear this, and we're gonna graph it. Let's graph 3x, nope, 3x squared minus 4x plus 2. So we know that none of these solutions are real, right? So these are, if you want to even go further, these solutions are imaginary solutions. These are imaginary, how do you spell it? Imaginary solutions. Oh my goodness, I am a horrible speller. Um, so they are imaginary solutions, right? So you should kind of realize that they're never going to actually touch zero, right? Um, okay, does that kind of make sense? The fact that they're imaginary solutions, so they're never going to actually imagine. This is supposed to be a imaginary solution. These are imaginary solutions. And how do you know that? So again, my discriminant here, what is my discriminant? So my discriminant is just b squared minus 4ac, right? Not the square root, not anything about that, just the discriminant itself. So if my discriminant, so if b squared minus 4ac is greater than 0, you're going to have two real solutions. Now if b squared minus 4ac is equal to 0, you're going to have one real solution. And now if b squared minus 4ac is less than 0, you're going to have two imaginary solutions, okay? So we know that our discriminant here, this was the discriminant, was -8. So if it was negative, right? So therefore, we have two imaginary solutions, right? And you should think about what the other solutions were. For example, here our two solutions were real numbers, right? They were real numbers, and our discriminant here was positive. It was 81. We didn't have a discriminant that was 0, which is good, but that will make you realize that there's only going to be one solution for that, right? Because if the square root of 0, the square root of 0 would just be 0. Exactly. Okay. I hope that made some sense. Um, please come to office hours. This was a lot. Um, yeah, send me a Teams if you have any questions. Okay. Hope you're having a great day.